Hi students, welcome to our channel. Today our topic is traveling salesperson problem. Okay, traveling salesperson problem. We are going to solve this using dynamic programming. Now before going to our procedure, that is dynamic programming phenomenon, just we'll think what is meant by traveling salesperson. Okay, traveling salesperson. Traveling salesperson is nothing but, suppose there are places or cities, otherwise some sightseeing place, anything. If there are some places, you should consider anything as source vertex. Should consider anything as source vertex. Whenever you are considering a source vertex, after visiting that one place, you should not revisit the remaining vertices. Only exactly once you have to visit the remaining vertices except the source vertex. At last, after completing all vertices, then you are going to revisit again the starting vertex. That is the main phenomenon, otherwise the definition of traveling salesperson problem. That is, whenever there are n vertices in a graph, then you will consider some vertex as source. In traveling salesperson problem, the main phenomenon is, here you have to find out the minimum distance to cover all the vertices. You have to find a path in such way that the path will start from source vertex and covers all vertices and again goes back to the source vertex. This is definition, otherwise the phenomenon in the traveling salesperson problem. Okay. Now we will see the possibilities. In general, we will see the possibilities. Now why we have went for dynamic programming, and in general what is the possibilities we will look after. Suppose A. Okay. A is an vertex. B is an vertex. C is an vertex. We will think so. We will think the same graph. For example, what are the possibilities? If this is a given graph, what are the possibilities to find out the solution for traveling salesperson problem? Suppose A is starting vertex. From A you have three possibilities. You can go to B, you can go to C, you can go to D. Next, from B you have two possibilities, that is either C or D. From C you have two possibilities again, from B or D also, B and C. And at last, here D, here C, here D, here B, here C, here B. And at last again they will go to A only. All vertices, all the, whenever you start reaching the all vertices, then again they will reach the A itself. Okay. This is how the different possibilities of your traveling salesperson problem. The path may be A to B, B to C, C to D, again D to A. And these vertices may change. The starting and ending vertex, that source vertex, will not change. That is, whenever you are consider something as source vertex, that will be the same. Okay, this is about different possibilities in your traveling salesperson problem for the given graph. Okay, now we'll see whether how we are going to use dynamic programming approach for solving the traveling salesperson problem. What is the main criteria we'll follow in dynamic programming? You have to find the optimal solution, means you have to find the best solution. And one more thing, you have to restore the solutions which are restored previously, you have to reuse them. You don't need to find it again and again. Means you are finding some solution in one part, then you have to reuse it somewhere. These two phenomena you have to follow when you are using dynamic programming. Now we will see how we are going to solve this problem using dynamic programming. Now this is the given graph. Okay, this is the given graph. For the given graph, this is the adjacency matrix. As you know, this is cost matrix, adjacency matrix. Okay, and one more thing you should mind it, that traveling salesperson problem, there should be weighted graph. that may be directed or undirected. It may be directed graph, otherwise it may be undirected graph, but it should be weighted graph. These two you should remember. Now this is the given graph. For the given graph, first thing you have to note down the cost matrix. Otherwise, you may consider that as cost, that is distance or something. Otherwise, adjacency matrix. Using the given graph, you have to note down that. That is first step. After note downing the adjacency matrix, you have to apply dynamic programming. Before applying dynamic programming, you have to memorize this formula. Okay, this is the formula used in your dynamic programming. That is cost of I comma s. This is cost function used in dynamic programming. G of I comma s. Here s is nothing but set of vertices. S is nothing but set of vertices other than the source vertex. Here I will become your source. Other than the source vertices, remaining will be included in the set S is equal to, how you will find out, minimum j belongs to S, Cij, that means cost from I to j. Cij is nothing but is equal to 0 if I equal to j. Cij is equal to some cost if Ij belongs to graph. Means that Ij, an edge is existing in the graph, then you are writing the cost. Okay, plus g of j comma s minus j. Means j belongs to s. That j is nothing but some element in the set s. Now j comma s minus j. This one, it will be well understood whenever you are solving the problem. This formula, how you are applying that formula in your given dynamic programming, that you can be understood well whenever you are going for the problem. Okay. Now we'll see the problem for this. We'll solve the problem. I am rubbing the, since we have the cost matrix, we don't need to worry about that graph. Already we have drawn the cost matrix for that. Now we'll solve the problem. For solving the problem, we have some procedure. That is step 1, step 2, like that you have some procedure. For that, first thing, mod s is equal to 0. Mod s is equal to 0. Now we are considering that s is equal to 0. S is equal to 0 means that is an empty set. Okay. Here one more thing, it also indicates that no vertex is unvisited. All vertices are visited. That then only your set becomes empty set. Now we'll see the same example, A, B, C and D. For the given graph, all vertices are visited, and whenever you want to calculate the cost between this one, this last level, these are the different levels. Okay, these are different levels. Whenever you want to find the cost between D and A, why? You have to go back to A itself. Whenever you want to find the cost of D, you will find directly G of B comma pi, because pi is an empty set. Since there is no set, this formula only we are expanding, but since there is no set, we'll think it as empty set. But if you are in B, if here suppose that is there is B, that means you are again going from B to the source vertex A only. So this will be equal to G of B comma A only. The same answer only you will get. Okay, the same answer you will get whenever you are finding that. In such way, when the set is empty, that is S, mod S is equal to 0, the number of unvisited vertices are 0. There are no unvisited vertices. You have visited all vertices. Then G of B comma pi is equal to G of B comma A. What is G of B comma A? From A to B or B to A, same, since it is undirected graph, B to A, fine. This is step 1. In that step 1 part we have solved. Now G of C comma pi is nothing but G of C comma again A only, because if there is no other this vertex to visit, then definitely it will go to source vertex only. Next, as it is traveling salesperson problem. C comma A is equal to C to A, that is 3. Okay. Next, G of D comma pi, that is equal to G of D comma A. What is that? D to A, that is 2. This is how we will calculate step 1. Nothing more complicated here. Whenever you are visiting, there is no unvisited vertices in the given set S. That means there is no vertex to visit. It also gives a clue that you can directly go to source. That's why G of B comma pi. Why we are taking pi here? Since it is an empty set. You have to take pi since you are calculating for this. Then directly G of B comma A. Why? Whenever you are reaching that no other vertex to visit, you will directly go to source. In such way, you will calculate step 1. Note down, this is very important because using this step 1 only, you are going to resolve the other steps. That's why it is important. Next, when unvisited vertex is 1, means number of unvisited vertices is only 1 left. Now, in this case only, I am again and drawing the same possibilities only. You no need to confuse. For your re-understanding, I am drawing more times. Here C and D, here C. Here B and D. Here, after B, C. After D, B. Okay, vice versa. Now, whenever you are in this level, we have solved. You are going to A. Now you are in this level, means you are at C. That means whenever you have only one visited, this level all the vertices, there is only unvisited vertex is only one left. In such case, what will be the formula? Suppose you are in B. Suppose you are in B. In this case, D is unvisited. Now, so that you have to calculate one by one. G of, so we will think B. From B we will start. From B, G of B comma D. We will get all vertices also. First we will think B of D. So minimum of D belongs to S. We are applying the formula. D is nothing but here J, S is S. Next, see cost of BD. Because what is the cost actually? IJ. Here I is this one and J is this one. So IJ plus G of D comma S. What is D comma S? D is nothing but already we are taking from here because here it is J and S minus D. Already what we are having in S? D only. So D minus D. What will get? D minus D. Empty. That means pi. That's why cost of CBD plus G of D comma pi. This is how we got this equation. Means using the formula which is stated above for dynamic programming traveling salesperson, we are applying that formula for this step. Then you will get like this: CBD plus G of D comma pi. Okay, CBD plus G of D comma pi. Now G of D comma pi is already given. We can directly, before going to that, C of BD. CBD means cost of B to D. B to D, 7. 7 plus G of D comma pi, what is the value? 9, 2. So cost from B to D is 7. B to D is 7. Okay. 7 plus 2, 9. Okay. Is it clear? Now, in the same way, we will calculate G of C comma D. Otherwise, we'll remain in vertex B only. B, C. There is a possibility, right? You may be in B. You may be in B. Okay. This is only one visited vertex. Here, if you get B, C, you may be having C also. So, we will find out G of B comma C. That means you are starting from A, you are visiting some D, then again you are coming from B, and now remaining vertex is only C. In such case, same formula. I am not writing the formula again and again. You can directly apply. You will get cost of BC. Applying this formula plus G of C comma pi. Okay. Since you are getting d comma pi here, you will get c comma pi. Okay, this is how, since it is j, here also you have solved j only. This is how you will expand this. So now cost of BC, B to C, that is nothing but 10. 10 plus C comma pi is 3, that equal to 2, 13. Okay, this is one more thing. Now, in the same way, you are going to solve G of, now B vertex is over. You may be at C also, right? You may be at C. What are the possibilities? You may go to B. Otherwise, you may go to, from C, you may go to D also. One more possibility also it is there. You may be at D. You may go to C. Otherwise, you may go to C from D, B also. Means these are the possibilities if the source vertex is B, C and D. These are the three possibilities whenever the unvisited vertex is 1. Now, cost of, I am applying the formula, nothing more complicated here. I am just applying the same formula here. No need to confuse more. Cost of CB, since it is weighted undirected graph, cost of BC otherwise cost of CB will be same. But if it is an weighted directed graph, you will be having the difference. So since it is undirected graph, it may be same. G of B comma pi. Okay. In the same way, cost of CD plus G of D comma pi. In the same way, cost of DC plus G of C comma pi. In the same way, cost of dB plus G of B comma pi. Now you have to solve all this using the given matrix. Now this one, all these values are already found out in step 1. That is why we are using the dynamic programming. Means we are reusing the same solution. Whichever is found out in earlier steps, we are reusing the solution which is restored earlier. That is the main purpose we are using dynamic programming here. Cost of CB is nothing but same 10 plus G of B comma pi, that is 5. 15. Okay. Next, cost of CD, C to D, that is 1. 1 plus G of D comma pi, that is 2. 3. Next, cost of DC also will be 1 and C comma pi is nothing but 3. So it is 4. Next, DB, D to B, that is 7. 7 plus B comma pi, that is 5. That is 12. Okay, this is how we have got the values for step 1. Sorry, step 2. This is step 2. Using the formula whichever is described earlier about dynamic programming for traveling salesperson problem, we are solving this. We are substituting the formula as it is. Whenever it is, this is considered as I, this is considered as J. G of I comma S. And here we are considering one element, right? The set inside element, that will be considered as J. Okay. Now we are going to see the next step. Now you can guess it out, right? We have followed S is equal to 0, S is equal to 1. Now S is equal to 2 means number of unvisited vertices will be 2. Okay. Now S is equal to 2. You may get a doubt. Where we have to stop, I'll describe in area. I'll tell in area coming upcoming classes. S is equal to 2. When S is equal to 2, you are in G of B. Okay. What will be the possibilities? C comma D. Now you will have the actual minimum. What is the concept of minimum here? Minimum of cost of BC. minimum of cost of BD also, plus here this is I1's, see this is J, this is J. Now G of J comma, right? So what is J here? First time C comma, okay, S minus S. What is S now? C comma D minus what is J? C. So C comma D minus C, you will get D here. Here also same, G of D comma C comma D minus D, you will get C here. C comma D minus D, you will get C. D will be cancelled, right? So I will get C. Now what is the problem now? Minimum of CBC plus G of C comma D in first step. C comma D minus C, you get D. Like this, since it is in set version. C comma BD plus G of D comma C. Okay, now these two elements you are going to get from here. You are going to get from here. You already find it on step 2. You reuse that here. Now what you'll get? CBC. CBC. Cost of BC. B to C. 10 plus C comma D. What is C comma D? This one. 3. 13. But then B to D. B to D. That is 7. 7 plus G of D comma C. D comma C. That is 4. That is 11. So which is minimum here? 11. So level will be, for this 11 will be your answer. Okay. This is in step 3. Step 3. That is S is equal to 2. Part 1. Now here using the same procedure we will solve G of C comma BD. Same procedure, we are applying the formula. Then G of DBC will get minimum value 13 and G of D comma BC will get minimum value 16. Means minimum of this minimum value you have to take. After finding this, we will go for G of A comma B comma C comma D. That means here step 4, that is set is equal to unvisited vertices is equal to 3. Okay, we will find out this one. Now this is J value here. J. Okay. J. Now cost of AB, cost of AC and cost of AD 5, 3 and 2 using the adjacency matrix. G of B comma C comma D, C comma BD, D comma BC. This one we will use equation using the step 3. We will find out 11. This is minimum and 13 is minimum and 16. In that way we will get this one. Now you are getting two values are same, means both path gives you feasible optimal solution using the dynamic programming. Both paths of this traveling salesperson will give you the feasible solution. This is about your traveling salesperson problem using dynamic programming. Now we'll find out the path. This here you got two solutions here. We'll see the path also for that. You can, after seeing the path, you may get a clear understanding. See, from A, which are the paths? A to B. Okay. Next, in that B comma C comma D, which one you are taking? Minimum one. So this is 11. So B comma D, D comma C. In that way you are going. B to D, D to C you are going. Again you will be reaching A only. This is one path. This is one path. Next, A to, since this one, A to C. After going to C, here you are following D to B. So you are going to D, then to B, again to A. These are the possible paths. Okay. These are the possible paths. Now, on request of my students, I will revise once everything in Telugu. On request of my students, I will revise all, I will give synopsis in Telugu so that it will be better understanding for my students. So, మనకు ఒక గ్రాఫ్ ఇస్తారు ఫస్ట్ థింగ్. ఆ గ్రాఫ్ నుంచి మనం తీసుకోవాల్సింది అడ్జసెన్సీ మ్యాట్రిక్స్. నేను లైన్ బై లైన్ చెప్పలేను, బట్ మెయిన్ థింగ్స్ ఒకసారి రివైజ్ చేస్తాను. మనం అడ్జసెన్సీ మ్యాట్రిక్స్ డ్రా చేసుకున్న తర్వాత మన మెయిన్ కాన్సెప్ట్ ఏంటి, ఏ అనేది ఒక వర్టెక్స్, బిసిడి అనే వర్టెక్స్ అయితే ఒకదాన్ని సోర్స్ వర్టెక్స్ అనుకోవాలి, ఒకదాన్ని సోర్స్ వర్టెక్స్. సపోజ్ ఏ అనేది సోర్స్ వర్టెక్స్ అనుకుందాం. ఏ అనేది సోర్స్ వర్టెక్స్ అనుకుంటే, ఏ అనేది సోర్స్ వర్టెక్స్ అనుకుంటే నెక్స్ట్ ఏం చేస్తాం, బి సి డి, ఇలా డిఫరెంట్ పాసిబిలిటీస్. ఇక్కడ నుంచి సికి వెళ్ళొచ్చు, ఇక్కడ నుంచి డికి వెళ్ళొచ్చు, తర్వాత డి, తర్వాత సి, ఇలా డిఫరెంట్ పాసిబిలిటీస్ వస్తాయి. మనం ఏం చేస్తున్నాము, డైనమిక్ ప్రోగ్రామింగ్ యూజ్ చేయాలంటున్నాం. అంటే యూజ్ చేసిన సొల్యూషన్ మళ్ళీ మళ్ళీ యూజ్ చేయాలి, అట్ ద సేమ్ టైం ఆప్టిమల్ గా ఉండాలి. దీనికోసం మనం ఒక ఫార్ములా యూజ్ చేస్తున్నాం, జి ఆఫ్ ఐ కమా ఎస్ ఈజ్ ఈక్వల్ టు, ఇక్కడ ఎస్ అంటే సెట్ ఆఫ్ వర్టిసెస్ ఎక్సెప్ట్ రిమైనింగ్ దిస్ ఐ. ఐ అనేది సోర్స్ వర్టెక్స్. ఇదే మన మెయిన్ ఫార్ములా. ఈ ఫార్ములాని ఎక్స్పాండ్ చేస్తూ వచ్చాం. ఫస్ట్ థింగ్, ఎస్ ఈజ్ ఈక్వల్ టు 0. మోడ్ ఎస్ ఈజ్ ఈక్వల్ టు 0 అంటే రిమైనింగ్ అన్విజిటెడ్ వర్టెక్స్ ఈ లెవెల్లో ఉన్నాం అనుకోవాలి. అన్విజిటెడ్ వర్టెక్సెస్ ఐ వదిలేసేయండి, ఇంకేమీ లేవనేసి అర్థం. నెక్స్ట్ మళ్ళీ ఎస్ ఈజ్ ఈక్వల్ టు 1 చేసాం అంటే ఇక్కడ ఉన్నాం ఈ లెవెల్లో. ఇక్కడ రిమైనింగ్ అన్విజిటెడ్ వర్టెక్సెస్ ఎన్ని ఉండొచ్చు, ఇక్కడ ఉంటే సపోజ్ ఇక్కడ ఉంటే 1, ఇక్కడ ఉంటే 2 వర్టెక్సెస్, సో ఇక్కడ ఉంటే 1 వర్టెక్స్. సో ఈ లెవెల్లో ఉన్నాం. నెక్స్ట్ రిమైనింగ్ అన్వర్టెక్సెస్ 2. సో ఇలా సాల్వ్ చేసినప్పుడు మనం ఆ ఫార్ములా అప్లై చేస్తూ వచ్చాం. ఆ ఫార్ములా అప్లై చేసినప్పుడు ఎస్ ఈజ్ ఈక్వల్ టు 1 దగ్గర ఎస్ ఈజ్ ఈక్వల్ టు 0 వాల్యూస్ వాడడం, ఎస్ ఈజ్ ఈక్వల్ టు 2 దగ్గర ఎస్ ఈజ్ ఈక్వల్ టు 1 వాల్యూ వాడడం, ఇక్కడ ఎస్ ఈజ్ ఈక్వల్ టు 2 ఫైండ్ అవుట్ చేసాం యూజింగ్ ఎస్ ఈజ్ ఈక్వల్ టు 1. ఈ వాల్యూస్ అన్ని తర్వాత ఎస్ ఈజ్ ఈక్వల్ టు 3. మనం ఇక్కడతో ప్రొసీజర్ ఆపేయాలి, బికాస్ మన నెంబర్ ఆఫ్ వర్టిసెస్ 4 అంటే, సో 0 1 2 3 4 స్టెప్స్ అంతే. లేదా మనం స్టెప్ 1 నుంచి వస్తే ఇది స్టెప్ 4. సో 4 వర్టిసెస్ కాబట్టి 4 టైమ్స్ చూసుకుంటాం. సో నెంబర్ ఆఫ్ వర్టిసెస్ 4 అన్నప్పుడు మోడ్ ఎస్ 3 దగ్గర మీ ప్రొసీజర్ ఆగిపోవాలి. ఇది ఈ ప్రొసీజర్లో సాల్వ్ చేసుకుంటూ వస్తే యు ఆర్ గెటింగ్ 2 పార్ట్స్. ఆ 2 పార్ట్స్ ఏమనేసి నేను డిస్క్రైబ్ చేశాను. ఎందుకు, ఏ నుంచి బికి వెళ్తున్నాం, బి తర్వాత ఏ పాత్ తీసుకోవాలి, బి నుంచి సి కైనా వెళ్ళొచ్చు, బి నుంచి డి కైనా వెళ్ళొచ్చు. ఏ పాత్ తీసుకుంటాం ఇక్కడ, మినిమం. సో 11 అనేది మినిమం కాబట్టి బి నుంచి డికి వెళ్ళి డి నుంచి సికి వెళ్ళాం. సో ఆ పాతే కన్సిడర్ చేసి మీకు చెప్పాను. సో ఇది కూడా యాక్సెప్టబుల్, ఏ నుంచి సికి, సి నుంచి బి టు డి. సో ఈ గ్రాఫ్లో ఏది తీసుకున్నాము, సి టు బి టు డి అన్నప్పుడు దీంట్లో మినిమం ఏది, దిస్ వన్. సి నుంచి డికి వెళ్ళాం, డి తర్వాత బికి వెళ్ళాం. సో 2 పార్ట్స్ యాక్సెప్టబుల్. దిస్ ఈస్ అబౌట్ యువర్ ట్రావెలింగ్ సేల్స్ పర్సన్ ప్రాబ్లమ్ యూజింగ్ డైనమిక్ ప్రోగ్రామింగ్. ఫర్ ఎనీ క్వైరీస్ you can ping me in WhatsApp. Otherwise you can keep your doubts in your comment section. Thank you.